Imagine an ocean larger than all the seas on Earth, combined, hidden beneath a frozen crust, hundreds of kilometres thick. That ocean does not belong to Earth, but to Ganymede, the largest moon in the solar system and one of Jupiter's Galilean satellites. But size and water are not the only things that make Ganymede extraordinary. Beneath its icy shell lies a puzzle that continues to defy scientists, a magnetic field unique among moons, and one that should not exist. Today, let's take a journey across this distant world. Together, we'll uncover its immense scale, its deep oceans, the tantalizing possibility of life, and the great scientific mystery surrounding its inner core. By the end, you may find yourself looking at the solar system in a whole new way. So what exactly makes Ganymede so special? To answer that, we must begin with the basics, where it sits in the Jovian system and why it holds the title of the solar system's true giant moon. Jupiter is surrounded by at least 79 moons, but 4 stand out above the rest: the Galilean moons, Io, Europa, Callisto and Ganymede. Discovered by Galileo Galilei in 1610, they transformed our understanding of the cosmos, proving that not everything revolves around Earth. Of these 4, Ganymede is the undisputed heavyweight. With a diameter of 5,268 kilometers, it is larger than Mercury itself, though far less massive. For comparison, Ganymede is about 41% the size of Earth, yet over 2% larger than Saturn's Titan, once thought to be the biggest moon. To help picture it, imagine replacing Earth with Ganymede. Its sphere would stretch across the entire North American continent. Yet, despite its volume being 26% greater than Mercury's, its density is far lower, only 1.9 grams per cubic centimetre, compared to Mercury's 5.4. Why the difference? The answer lies not just in rock, but in water. This giant moon is made of roughly half silicate rock and half water ice. And as we'll see, it is this unusual mix that hides one of Ganymede's most astonishing secrets, a hidden ocean vast beyond imagination. Beneath Ganymede's surface lies a world of ice and water. Its icy crust extends about 150 kilometres deep, and below that rests a massive ocean. When we say massive, let's put it into perspective. Earth's oceans are on average 4 kilometres deep. Ganymede's an average of 100 kilometres. That makes it 10 times deeper, and it means this single moon holds more water than all of Earth's oceans combined. Water makes up nearly half of Ganymede's total composition, with the remainder being silicate rock, small amounts of metal and other ices. In fact, this balance between rock and water gives Ganymede its relatively low density compared to rocky planets. The name Ganymede itself comes from Greek mythology. Ganymede was a beautiful youth taken by Zeus to serve as cupbearer to the gods, a role forever linked with water and service. In that sense, it feels fitting that the moon, named after him, now serves as Jupiter's great cup, carrying unimaginable quantities of water around the gas giant. But where there is water, there is always one question that follows: could this moon, frozen on the surface, yet rich in hidden oceans, harbour life? To explore that, we need to dive deeper into the unique environment of Ganymede. At first glance, the conditions might seem promising. After all, Ganymede not only holds a colossal ocean, but also possesses an atmosphere containing oxygen. But before you picture breathable air, let's be clear. This atmosphere is incredibly thin, measured in micropascals. In fact, it is 100 billion times less dense than Earth's atmosphere at sea level, far too tenuous to sustain human life or even complex ecosystems. Still, life does not always need sunlight or air. On Earth, entire ecosystems thrive deep under the oceans around hydrothermal vents, where chemical reactions rather than sunlight provide energy. Could something similar happen on Ganymede? The problem is that Ganymede's ocean lies so deep beneath the surface, under up to 150 kilometres of ice, that the pressure at its base may be high enough to force water back into solid ice. This means the liquid water might never come into contact with the rocky mantle, cutting it off from the minerals and heat that sustain life on Earth. However, there is an intriguing possibility. Evidence increasingly suggests that Ganymede's ocean may be salty. If that is the case, the salt would alter the ocean's behaviour, perhaps creating multiple layers separated by sheets of ice. In this scenario, the lowest layer could directly touch the rocky core, raising the chance that chemical reactions and maybe even microbial life could occur. It's far from confirmed, but the possibility keeps scientists fascinated. And as remarkable as this may be, it is not Ganymede's only mystery. In 1996, during a series of flybys, NASA's Galileo spacecraft made a startling discovery. Ganymede was producing its own magnetic field, the only moon in the solar system known to do so. The evidence came in the form of auroras shimmering in the moon's thin atmosphere. Observations from the Hubble Space Telescope revealed that these auroras shifted far less than expected, a clue, pointing toward the presence of a salty ocean beneath the ice. But the real mystery lies in the magnetic field itself. On Earth, our magnetic field comes from the motion of molten iron in the outer core, creating a geodynamo. But Ganymede is much smaller, and scientists long believed its core should have cooled and solidified long ago. A solid core cannot drive convection, and without that, no magnetic field should exist. Yet Ganymede proves otherwise. The field is there, strong enough to carve out its own miniature magnetosphere inside Jupiter's massive magnetic domain. While it does not shield the moon completely from radiation, it does reduce some of the harshest effects, making Ganymede more habitable than some of its neighbours. Why does this moon defy expectations? That question leads us to the forces tugging at Ganymede, forces strong enough to reshape entire worlds. Ganymede orbits Jupiter once every 7 days, but its path is not a perfect circle. Its slightly eccentric orbit means that at times it is closer to Jupiter and at others farther away. Each pass pulls and stretches the moon, then releases it again. This constant flexing produces friction, just as bending a paperclip back and forth eventually warms it in your hands. On a planetary scale, the heat generated is far more significant. This process is known as tidal heating, but there is more. Ganymede is locked in an intricate orbital resonance with its siblings Europa and Io. For every orbit, Ganymede makes Europa orbits Jupiter twice and Io 4 times. This is no coincidence. The moons tug on each other, maintaining this precise balance, known as Laplace resonance. These gravitational interactions continually stir Ganymede, preventing its orbit from settling into a perfect circle and keeping the tidal heating active. Perhaps this hidden furnace is enough to maintain a partially molten core, and with it, the magnetic field that puzzles scientists to this day. Looking at Ganymede's surface, we find evidence of this inner turmoil written across its icy crust. About 1/3 of the surface is covered in dark regions, heavily cratered and ancient. The remaining 2/3 are brighter, younger terrains, etched with ridges and grooves, stretching for thousands of kilometres and rising up to 700 metres high. These lighter regions suggest tectonic or cryovolcanic activity, perhaps driven by the tidal stresses Ganymede has endured over billions of years. They may be scars from an unstable past when the moon's interior was more active, reshaping its surface. Even without landings, scientists have used Ganymede's auroras to probe its interior. The patterns of these glowing lights confirmed the presence of the subsurface ocean, all from millions of kilometres away. The surface, in effect, is a cosmic manuscript holding the history of forces that continue to shape this extraordinary moon. For now, many questions remain unanswered, but help is on the way. In 2022, the European Space Agency launched JUICE, the Jupiter Icy Moons Explorer. After a decade-long journey, it will arrive in the Jovian system in the 2030s and eventually enter orbit around Ganymede itself. JUICE's mission is ambitious to study Ganymede, Europa and Callisto in detail and to search for clues about their ocean's geology and potential habitability. For the first time, we may get close enough to test whether Ganymede's magnetic field is truly sustained by a molten core and to learn just how deep and salty its hidden seas might be. Until then, Ganymede keeps its secrets. But with each discovery, we get a little closer to understanding this frozen world. Studying Ganymede is not just about learning the story of one moon. It is about piecing together how our solar system formed and how worlds evolve under the influence of giants like Jupiter. The Jovian system is a laboratory of cosmic dynamics, with Ganymede as its most intriguing experiment. Perhaps in its oceans or in its mysterious magnetic heart lies a key to understanding not just moons, but planets, and maybe even the conditions for life elsewhere in the universe. Until the next great mission, we can only imagine what discoveries await beneath Ganymede's ice. But one thing is certain, exploring it will bring us closer to answering one of humanity's oldest questions: are we alone,